right, welcome to the Explainer. Today, we're going to break down one of the coolest and, honestly, most understandable tools in all of machine learning, the decision tree.
So let's kick things off with a problem you've probably run into. You're trying to figure something out, right? But you've got all these different things to think about, and it's hard to know where to even start.
Okay, picture this. You want to know if the local team is going to play today. All you have is the weather forecast. Seems easy enough, right? But wait, what part of the forecast is the most important? Is it the sun, the wind, the humidity? How do you decide?
Well, lucky for us, we've got some history to work with. This table here shows what the weather was like for past games. Was it sunny, was it humid, was it windy, and whether they ended up playing or not. What we want to do is find some kind of pattern, some set of rules in this data that'll let us make a really good guess for future games.
So, how do we take all this messy data and turn it into something that can actually give us an answer? Well, that's where the decision tree comes in.
A decision tree, it pretty much does what it sounds like. It's an algorithm that looks like a tree. And the way it works is by asking a series of questions. Those are called internal nodes to get us to a final answer, which we call a leaf node. It's basically a path from a question to a conclusion. Really, the easiest way to picture it is just as a super smart flowchart. It just asks one simple question, then another, and another. And each answer leads you down a path until you land on the most likely outcome. Okay, so that's the what. But what about the how? How does the algorithm actually build this tree from our data? It all comes down to finding the very best place to start. The algorithm's first mission is to look at everything we've got, the outlook, humidity, the wind, and figure out which one of those is the absolute best question to ask first. And how does it know? Well, it uses some fancy math, things called Gini impurity or information gain, to find the question that splits the data most cleanly, the one that gives us the most bang for our buck right at the start. So in the world of decision trees, that first most important question is called the root node. Think of it as the trunk of our tree. Its whole job is to make that first big split in the data, to separate the play from the don't play outcomes into groups that are as pure as possible right from the get-go. So the algorithm crunches the numbers from our table and bingo! It figures out that the outlook is the single most powerful factor. So that's it. That's our root node. The question at the very top of our tree is going to be, what's the outlook? And just like that, this one question, our root node, splits all our data into three main branches, one for sunny, one for overcast, and one for rainy. So let's follow each path and see where it leads.
Okay, now check this out. The overcast branch is super interesting. Look at the data. Every single time the outlook was overcast, they played the game. That's a 100% pure answer. So this branch is done. It ends right here in what we call a leaf node. That's our final decision. Game over, no more questions needed down this path.
But the other two branches, sunny and rainy, not so easy. For both of those, sometimes they played and sometimes they didn't. It's all mixed up. We don't have a clear answer yet. So these aren't leaf nodes. They're what we call those internal nodes again, which just means we've got to ask more questions.
So what happens now? The algorithm hits a mixed bag. It can't just give up, right?
Of course not. It just keeps going. It grows more branches. So it takes just the data from the sunny days and asks, okay, for this group, what's the next best question? And it turns out it's about humidity. It does the exact same thing for the rainy day group and figures out the next best question there is about the wind. And this just keeps happening, this splitting and asking questions, making the groups purer and purer until every single possible path ends in a final decisive leaf node.
Now, I know, predicting a sports match based on weather seems pretty simple. But what's so powerful is that this exact same logic, asking the best question, splitting the data, and then doing it again and again, is used to solve some incredibly complicated problems out there in the real world.
And that's the key takeaway here. This is so much bigger than sports. Decision trees are working behind the scenes, right now, helping your bank decide if you're a good risk for a loan. They're helping doctors work through a checklist of symptoms to figure out a diagnosis. They're even helping companies figure out if you're about to cancel your subscription. It's everywhere.
And really, this is what data science is all about, isn't it? It's about finding the hidden story in a bunch of messy, raw information. It's about building a framework, just like this decision tree, that lets us make smarter choices based on actual evidence. Which brings us to one last big thought. As these decision trees get more and more complex, and as they make more and more important decisions in our lives, it brings up a really tough question of accountability.
When an algorithm denies your loan or suggests some medical treatment, who's actually responsible for that outcome? Who's on the hook? That's something we're all going to have to figure out.